Okay, let's start today's class. Uh, Hello,
Yes, sir.
hello. So I welcome you all for this NPTEL lecture. So this is week 10. We'll be discussing the concept related to a week number 11. So what I noticed in the last assignment, the week number 9 assignment, the questions which were there that was discussed by me already. So today I will not discuss that questions. Also the topics which are there in the next assignment, also some of them are covered. So some random questions I have today to discuss. So let's start today's class. So let's start with the first question. So tell me one thing. This is a triangular element. Uh, what precautions you will take to number these elements? Is it possible to name it like 1, 2, 3?
Yes, it seems okay.
Mm. So this is known as clockwise direction numbering.
Yes.
But in usually in FEM we don't do this. What we do? We do this as 1, 2, 3. So first question which I will discuss here will be why numbering of elements should be done in anti-clockwise direction. So if this is our triangular element, it's mandatory for you to do like this 1 2 3, not like in clockwise direction. So your coordinate will be x1 y1, x2 y2, and x3 y3. Okay, so I'll solve the part why it is so. Let's say temperature as the temperature of each element as the degree of freedom, and let's start solving that. So we know if we know the Pascal's triangle. So there are three element. So let's write one x square, xy, and y square. So temperature unknown variable. What you will write? You will write it as a naught plus a1x plus a2y. Anything else is required? No, only 3 degree of freedoms are there. So we required only 3. So let's start solving that. We'll write uh, t as 1 xy, a naught, a1, a2. At node 1, t1 equals to a naught plus a1 x1 plus a2 y1. t2 is equal to a naught plus a1 x2 plus a2 y2. t3 equals to a naught plus a1 x3 a2 y3. Just what I am doing, I am getting the shape function of the this element. So we can write this as t1, t2, t3 with 1 x1 y1, 1 x2 y2, 1 x3 y3 with a naught, a1, a2. So do you know the method of C while calculating the for calculating the shape function? Is it discussed in the class?
Method of what you saying?
Method of finding the shape functions using C matrix.
C matrix.
Yeah, like this. I don't know how he has written in the class. So this is your C
No, with
matrix.
the last class, means in this week's class,
Uh,
I think lecture 10,
uh,
the area triangle method was
I
discussed.
think this is the same thing. I think
I
so.
don't know.
See
It's
now,
L1, L2, L3, something like that. You was doing.
now you will get C inverse D. So you are getting till now. It's correct, or you missed
Yeah,
something?
maths. No, maths is fine
It's
still.
fine.
Yeah.
Huh? Okay. Then you will write T as X, which is this, and C inverse and D. So this can be written as N of D. So N here is X into C inverse. So when you will solve it, you can write it as, for 2D elasticity, you can write it as uh, U as, let's say for 2D
What
elasticity.
is X there? I couldn't get.
So see, X is, you are writing, you are putting this in this equation. This equation. You got A. So you are putting this A.
Yeah, means
A is
A
this.
should be C. You are writing one X and X Y1, right?
Yes,
That matrix you are
yes,
writing.
yes. One X, X1, Y1, one X2, Y2, and one X3, Y3.
And D is the unknown
D
matrix.
is the unknown matrix.
Okay.
So you are
D is the
putting this,
temperature
you
matrix.
are this T is this, you are putting this A
Okay.
into this matrix. So it is X into C inverse D.
Yeah, A is fine. Now T, what you are writing is
What I am doing,
T. You are writing.
I am putting this A in this equation. So this equation is T into X into A. And A we have found as C inverse D. So it is T into X C inverse D.
No, no. Again, first you are assuming the X as C. Now again you are assuming it as X. So confusing.
No,
I'm
no,
getting
no.
confused.
See, this equation is written as T is equal to XA. Is it okay?
Okay, fine. Okay.
Now you have to get the value of A. So how you have got the
Yes.
value of A? You have, so what you have done? You have calculated the value of A as C inverse D.
No, that is again no. It's first you are saying that T equals to X into A. Okay. Again you are writing the X as C.
No, 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 no. This is coming from this. C is. Oh wait. What has happened? C. Oh, sorry. T is this. T x is equal to A is this. T is equal to X A is here
T equals to this is X.
into A.
This is A.
Now here we are
Okay.
putting it. This is D. This
Okay.
is
So
full.
you are
This is full
okay.
D into C into A. You can remove
Okay,
this.
fine. So this is basically A is equals to C inverse
So
T.
D,
So
you will.
A you are putting
Uh,
A you are putting there. Okay, fine, fine.
so
Now
here,
get it.
from here you can get the value of N1, N2, and N3.
C inverse into T.
So this will be
D
T
means you are saying
T
T.
equals to N1, N2, N3 with T1, T2, T3. Okay.
Yes.
Now let's say in a 2D elasticity problem, you can write U as U1, N1, or directly we are solving the question why it is, why to take it as in the anti-clockwise direction. So when you get N as X C inverse, we'll obtain the C inverse for this matrix, means this we have to get the inverse of this, and when you find the determinant of this, which is required to find the inverse, you will get determinant of C as x2 y3 minus x3 y2 minus x1 y3 minus y2 plus y1, x3 minus x2. This is the determinant. When you simplify it, x2 y3 minus x3 y2 minus x1 y3 minus x3 y1 plus x2 y2 minus x2 y1. Okay, so yeah, this is the determinant in the of the C matrix. So what we can say, we can say this as in matrix D, which is the different degree of freedoms. We have listed the nodal points in sequence of 1, 2, 3 in anti-clockwise direction. If the clockwise direction is done, is used, last two rows of C matrix will interchange, and determinant C, which we called is as area, will become 2A. So C matrix is this. So when you interchange these two row and find the determinant, you will get a negative sign. And this, so when you solve this determinant, you will get a positive sign when you are using an anti-clockwise direction. But if you use a negative, if you use a clockwise direction, one of this row will be interchanging and it will give you a negative sign. And with the while solving, determinant C is equals to 2 of the area, so area cannot be negative, area will become negative. Hence we adopt the convention that nodes should be numbered in anti-clockwise direction. So is it clear? So whenever you will mention the nodes in the clockwise direction, this determinant will become negative, and this determinant is equals to the area of it, which cannot be negative. So it's a convention to use it in anti-clockwise direction. Is it fine?
Yes.
Okay. So let's go to the next question. So do you know what element is known as constant strain triangle?
Yes, means triangle with three nodes
Triangle with three nodes. Why is it known as?
because there is no variation of strain.
Okay, I'll show that.
Yes. Yes.
So next question is why three nodes triangle is known as constant strain triangle. So we'll prove this. So when we'll use the inverse of C, what we'll get, so since this all things we were doing for constant strain triangle only, we'll use the same result. We'll write C inverse as 1 upon 2A x2 y3 minus x3 y2 y2 minus y3 x3 minus x2 x3 y1 minus x1 y3 y3 minus y1 x1 minus x3. This will be x1 y2 minus x2 y1 y1 minus y2, x2 minus x1. Okay. So when you will get the shape function using this, you will get n1 as 1 upon 2a x2 y3 minus x3 y2 plus y2 minus y3 of x plus x3 minus x2 of y. Similarly, when you will write the n2, it will be from, since you are using forming n1, you are getting 2 3 here. When you make the n2, you will get 2, you will start from 2 and get the 3. So similar way n2 and 3 can be computed, and the numbering will be followed by this. So one question, this is 1, this is 2, this is 3. Tell me the shape of n1, how it will be. Like in 2D, 1D we have drawn like this. What will be the shape of n1 in this constant strain triangle?
Yeah, I think it's will linearly varying, no?
So it will increase at 1 and go like this and go like this. Is it okay?
Yes.
So 0 at other points and 1 at the 1. Okay. So when you will write the delta t for this, del t by del x and del t by del y, which is del n by del x of d and del n of del y of d. So B matrix, which is the D matrix, when you will solve it using the shape functions, you will get this matrix. So what can you observe from this? You see, this is a constant matrix. Why this is constant? There is no term of x and y. So irrespective of any x and y, this matrix only depend on the coordinates of the vertices of the triangle. So whenever you are taking a three noded triangular, strain will be constant on it. So this element is known as constant strain triangle. Okay, correct? Understood?
Yes.
Okay, let's go to another question. How do you check convergence of an unknown variable, or we can say a solution also? So you have a let's say you have a unknown degree of freedom, let's say u. How will you check that it is converging or not?
Means there are a lot of methods, but I think one is simplest is at a particular point we can check the value with some messing, and we increase the messing, means the number of elements, the mesh size. We can refine the mesh and check the solution. And when the solution stops changing much, then we can say that we have achieved convergence.
So it's the means it's the conventional method you are telling. You are solving it, then saying that it is below the tolerance. But before starting the solution, means when you assume it, the unknown variable as like this, you can directly comment on it. Will it converge or not? So for that convergence check, before only you have to use. It's not that you can assume anything and then you solve it, then you say no, no, it's not converging, we can change our the assumed degree of freedom. So initially you have to do take care of two things in convergence. One is completeness and other is continuity, or continuity, or you can also say compatibility. So if you assume the degree of freedom such that these two conditions are satisfied, you can say that your solution will reach to convergence. So what these conditions are, I'll clear that also. Okay, the first is completeness. So whenever you assume a variable, let's say a naught plus a1x plus a1y, so what you should take care that all lower terms are included and no series term is omitted. If this is satisfied, your assumed degree of freedom, the function of an assumed degree of freedom is complete. So for that you can't take like this, you take this, you take 1x and then you took directly x square, x cube. So in this term x square is not there, so this is not complete. So these things you have to take care. Also the initial terms, maybe you start from x2 a2 x square a3 x cube, this is also not valid because a1 a0 and a1 are not included, so not complete. Okay, so okay, this is the first condition. The next condition is continuity or compatibility. How to check this? Let's say you have a triangular elements connected like this. Let's say this is I node, this is J node, this is K node, this is N node. So as temperature at nodal points J and K, which is the which is constant to both of the triangle connected ones, are same. For two elements, and since they vary linearly between nodal points J and K, it follows that temperature varies in continuous manner. Now the what question can arise, that let's say we have taken these two elements, but when we are taking this as J node, this is K node, when we initially we will take this at J, we'll solve this for the same thing, this for UJ, this for UK, this for UK, then obviously this will be same. But the problem is what you can take, let's say you take this as three noded triangle and you take this as more than that. Now what will happen? In this node, in this triangle, it will vary linearly. But in this well, it will vary quadrately. So obviously, these two, this line between the two elements is not in continuous. So you have to take care that whenever there is a connection between two elements, each should follow the same linearity or the quadratic rule. Means number of nodes should be constant in the both the elements for the connection. Is it okay? Is it clear?
Yes, yes,
Okay.
yes.
So next question. So next question I have taken. Can you tell me why isoparametric elements are used? Means every time we convert the x and y into some another natural coordinate system, then try to solve it.
I think I haven't given it much thought, but I think to make the calculation easier.
One reason is that, but the major reason I'll tell you now. What is the reasoning behind to convert it into the isoparametric element? So let's use a compatibility check or the continuity check we have used in the last question. Let's say we have two rectangular with 1 2 3 4 5 6. This is element 1, this is element 2. So along inter element boundary 2 5, since x is constant, so linear variable variation in y, correct? Means this is only two nodes here, so this will be linear variation in both, not a issue. So t2 and so thus this is compatible. Now so now however it is important that for compatibility or the continuous, the connected member of the element should be parallel to axis. Now let's say if it is not parallel, what will happen? Let's say your connected member is like this, then 1 2 3 4 5 and 6. Now let's see what is happening. In common boundary 2 5, y is equal to ax plus b. Now we'll substitute this in the assumed t, which was a naught plus a1 x plus a2 y plus a3 xy. So this was the assumed what we'll be assuming for the four noded rectangular element. So we'll put the value of y in this. We'll get a1x plus a2. This is ax plus b plus a3 x of ax plus b. Then a naught plus a2b plus a1 plus a2a plus a3b x of a3a x square. So what is the thing to be observed here is this: the variation of field variable is quadratic in X along the boundary 2 5. As you can see, this is x square. So the quadratic function is defined uniquely by 3 points, 3 nodes we can say. But here only 2 nodes are there. So your compatibility condition won't be satisfied. Thus, whenever we have a member like this where one of the member is which is not parallel, or like this is our body, let's say this is our body. For doing the FEM analysis, we are bound to take this member like this. You can't take this as like the rectangular one. So the members which are not parallel to the axis, you can't directly model them, because it will not follow the compatibility condition. For them, you have to convert them into the rectangular in a natural coordinate system. Then only you can solve it. So whenever someone asks you why you are using a this isoparametric formulation for the FEM analysis, there are two reasons. One is, yes, the integration becomes easier, and another is that whenever you have to model the elements which are not parallel to the axes, then you are bound to use the isoparametric elements. So is it understood? I think this is
Yes,
clear.
sir.
Yes. Okay, now let's take another question. This is question number 5. Okay, so explain the rate of convergence of a FEM problem. How can you check the rate of convergence of the FEM problem? Before that, what do you understand what by the rate of convergence?
How quickly the solution is getting to the convergence one.
Correct. So the rate of convergence provide information on how fast the approximate solution converges towards the exact solution. So we have to check this out how it is done. So whenever we do a solution, FEM solution, we write the, let's take a 2D problem so that we have a x and y also. So let's take a field variable t xy as a1 plus a2x plus a3y plus a4x square plus a5xy plus a6y square and some constant r power 3. All two terms I have written, and the third I have assumed as the with the constant. We can ignore them. let's say a1 and a2, they are all constants. Now in a region which contains point x naught y naught, we now assume approximation. We now assume that approximation to the true field is taken as so T apparent we can write, means we have taken all the terms here, so we can write this is the correct solution. Let's say T apparent which belongs in x and y, it will be a1 a2x plus a3y plus a4x square plus a5xy plus a6y square. Okay, so in apparent solution, what we are, I mean, approximate solution, what we are taking only the two degree terms, and in true solution, it was all with the order 3 also. So when you subtract to get the error in it, txy minus t approximate, you will get only cr power cube. So this is the this is the error, and it's in the power of cube. So we now consider a finite element which contains a point x naught y naught, and let h denotes the maximum distance from point x naught y naught. So we are assuming the element length as h. Now we have to find the maximum error, which will be t minus t approximate maximum c of h cube. Now if we replace element of size h with size alpha h, means now what we are studying, we are getting that how we are changing the length of the element and what it affects in the error. Means we have studied if we reduce the size of the element, we can improve the solution, but how much can we improve can be studied by this. So let's say we have changed the element length as alpha h. Now what we'll write, this t minus t approximate maximum will become alpha cube of t minus t, this alpha h for, this is for th approximate maximum. So is these two lines clear? Till now, is it clear? Should I go ahead? If you
Just a minute. If we replace the part of h with size alpha h, so you are replacing h with
alpha h. Right? So what I have done, this is the solution for h. Means you, if you are you have an element.
Yes, yes.
Clear, na?
It's clear.
Yes. So now we can. So this is the power which how this was the previous error. This is the new error, and this is the value how it is reducing. So let's say we have taken alpha is 1/2. So this new error will reduce by 1/2 cube of old error. This old error and new error is clear, na?
Old is the, I think, the
Old
absolute
when
error.
we are using it is at edge. Now we are using is h by 2.
Got it.
Should I do it again?
No, no, I get it.
You got it, na? So when we are
Alpha
using,
is the factor by which the
we are
size is
reducing the
reduced.
element.
Right? Yes.
So when we reduce the element by half, the error will reduce by 1 by 2 cube. So it will be 1 by 8 times. So this much error can be reduced when we make the elements as half. So I can summarize by writing it. This implies that with an element of size h by 2, the maximum error in approximation of 1 by 8 of the max error by using element size h. So whenever someone say you that or we can write one more, right? Then I can summarize that. So rate of convergence is of order 3. So whenever someone asks you how to improve the solution, you directly say that we can reduce the element size. So you can now quantify it also. You can directly say that if you are reducing it by 1 by 2, the 1 by 8 error will be reduced. Okay. So next question. Okay. Do you know what Malloch element is? It's a fancy word given to a one of the element.
No, I haven't any
Okay.
idea what this.
So this this rectangular with 4 elements, 4 nodes, sorry, is known as Malloch element. So let's write the u for this. Tell me what will be the u?
A0 plus A1x plus A2y plus A3xy.
Yeah. So in this xy term is known as parasitic. Have you heard of this?
No.
Okay. So this term is known as parasitic. So the next question is why xy term in unknown variable for Malloch element is known as parasitic element. Parasitic terms. Okay. So solve this now. Okay. So let's start with a triangular element. Then we'll compare it with the 4 noded also. So this is T as A1, A2x plus A3y. And if you see the exact, this is approximate. T exact what it will be? A1 plus A2x plus A3y plus C1 C1 r square. All the term with the second degree also will be there. So when you will find the error from this, it will be c1 h square. So when you reduce the element to alpha h, this will give you 1 by 4. I'm writing directly, or we can write it as new error is equal to 1 by 4 of old error. Since we are not taking the second term element, so it is 1 by 4 here. But now what happens when you take a Melosh element? When you take this element, we'll take T apparent as the T approximate as A1 plus A2x plus A3y plus A4xy. Even though we include one quadratic term to true solution, the order of convergence is still r square. Why is it so? T exact will be a1 plus a2x plus a3y plus a4xy. Still some of the x square y square is remaining, so still we write it as like this. So when you make it as the, you find the new error, you will still get a c1 r square. So still it is in conversion of the order 2. So this means that approximation that even if we take a quadratic term of xy in the solution, the convergence remains same. Thus, it do not contribute in convergence, hence known as parasitic term. Is it clear?
Yes, sir.
Okay, so this is the new thing I have for today. Now one more question I have taken, question number 7. So you have to find the n5 for this element. This is 1 2 3 4 5 6 7 8 9 10. Okay, now you have to find the n5 for this. Do you know how to do it?
Yeah, by the method that you taught us, no,
Yes,
using the lines, that I know.
lines.
But to the area coordinate, could you tell us?
Area
We can
coordinate is
find.
not I think in this. What, how to do it for this? You have to make line this. You have to make line this. It is based on the natural coordinate system.
Hmm.
This. Okay. Now you have to find this. Now here you have to use the natural coordinate as xi1, xi2, xi3 like this. I think this week these things are being covered.
Yes, yes.
Huh.
This week, No, this week no. It's covered in, I think, week 10.
Week 10 it was covered. Okay, no
Yeah.
problem.
This week
So
there is
this is week 10 only, na? No, week 10 is this is week 10 only.
okay, maybe.
Huh.
Actually, I was.
Torsion and the this is covered in this
Yeah, I
triangle
have
angle.
already completed the theory part. I
Okay.
was going to the question, so
So the now how to do this? This is 2. So this will be xi 2. Xi 2 equals to 0, and this will be xi 2 is equal to 1 by 3. You get how this is?
it's 1/3.
1/3, yes. Now what is this? This is xi 1 equals to 0. Now since you have to write n5, you will write it as xi 1 minus 0, xi 2 minus 0, and xi 2 minus 1 by 3. Now you have to compute the value as this. So for this, the value of xi 2, xi 1, so this is going, xi 1 is 1, where is this? This is 1. So I think this will be 1 by 3, 1 by 3, or 2 by 3, 2 by 3. And
No,
xi,
Xi1 is 1/3 only.
no,
Xi2 is 2
for
by 3.
n5.
For N5,
uh,
you are writing Xi1, no?
yes, xi 1 is for 2 by 3, no? This is
No, Xi1 is coming from the line 2, 3, right?
it
Starting
will be 1
from
by 3. It will be 1 by 3 because this is 0. This is 1 by 3, correct. Then xi 2 we have to find out. 2 is this. So xi 2 will come 2 by 3.
Xi2 will be 2 by
2
3.
by 3, yes. Now you have to compute this by putting in this. This is 1 by 3 minus 0. 2 by 3 minus 0. This is 2 by 3 minus 0. So when you solve this, you will get 9 by 2 xi 1, xi 2, and 3 xi 2 minus 1. So this is the different way of approaching to the problem. uh,
How, I have one question, means 1 by 3 minus 0 you're writing for
xi 1,
Xi1 minus 0, right?
yes, yes, yes.
For Xi1.
uh,
Then 2 by 3 you're writing for
xi 2.
Xi2, okay. Then another 2 by 3 is for?
This is also xi 2, na? Top one. These two are xi 2. I'm putting the value in this to normalize it, like the way we did na, that we have computed the value and divided by that.
Yeah.
So
Means what I do is I put the variable and then I put one constant ahead and then put the value of Xi1, Xi2 and equal N5 as 1.
So this is same thing, na?
Yeah, yeah.
The same thing.
You're doing it directly. Yeah.
Directly, yeah. So you divide by this value and you will get the normalized at n5.
Okay.
So let me see, it's 1 hour only. Can take anything else. Plane stress and plane strain is clear.
Yeah, that is done.
Means clear to you. Axis symmetry
No, axis symmetry
is not covered.
I think it's not covered.
Okay. 3D will be covered in the next 2 weeks, so I won't discuss them. I think I have all this for today. So since we didn't discuss the last week assignment, so it got over fast. Anything else you have the problem? I thought it's irrelevant to discuss that. It's already covered by me in the last week.
Yeah, last week you have already covered the problems. I think the assignments don't remember properly what the questions were. One question I got incorrect. I don't remember which one.
Okay. So today's question, I have taken some different questions which you won't get in any lecture notes or all.
Yeah,
So these are the different problems which someone can ask you and you can counter them, maybe
oh,
in the
yeah, I
interview
got
and
it.
all.
Yeah, yeah,
So
I got it. I'm just checking which one I got incorrect. Yeah, question number 7 actually, I was getting the answer as 0.0276 and 0.05.
which it was the
Weak 9?
thermal problem.
Uh, no, it was the plate with the huge, with a triangular load.
Triangular. Oh, sideways road.
Yeah, sideways.
I'll see what the solution is this, if they have given or not, or I'll try to get in the next week.
Yeah,
I'll see that.
because
Uh,
I was also getting confused with the option D, but in option D it's 0.005 mm. There is some mistake in the units, maybe.
in units, or sometimes it may be that their answer is also not correct. I've seen
Yeah,
many
yeah,
times,
I don't
but
know.
it's common for
So a
all.
lot of
So
time it has happened that
uh,
other questions are I'm getting correct, but the related question is getting incorrect. I don't know
yes,
how
yes.
it's happening.
Because they have made the old assignments, so sometimes they don't change the
Mm.
answers.
It could be.
Mm. No problem. They
Let's
will
say,
evaluate like that only. No worries. They will normalize in the later end.
I don't know. But
Mm.
in the score, I got one incorrect only.
Okay, okay.
So,
Mm. Okay, that's all for today. If you have a particular doubt, another any other, you can still ask. Otherwise, the class is
no,
over.
I don't. I mean, I think.
Okay,
Thank
thank
you.
you, thank you.
Thank you. Bye.
Bye.